What up, what up? All right, so we are going to get into some linearization now. What a mouthful, I know, right? So in this first problem, we have to find the linearization Lx of the function f at x equals blah, 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 blah at blah. Okay, so what does that mean? What is the linearization? That's what we need to know. This happens in about like 5 questions, so I'm going to be repeating myself. If you watch the other questions, whatever, it's important. Linearization means we're going to approximate our function with a line, with a straight line. Okay, so obviously that's not really going to work if our function is going all wacky, but if we approximate our function by a line, right where our line meets our function, we're actually going to be a reasonable approximator close to that x value. It's not going to be too far off, but the further you get away from that center point, the further away you could possibly be with your linear approximation. Okay, that's why for most of these questions we're approximating our function value near some sort of center point. Like in this case, it would be x equals 1, but we don't even have to approximate this question. This is just a little warm up, get our brain going. So yeah, so okay, I made you guys a Desmos graph, and it looks like this. Okay, so this is actually the function. Is it the function? Let me just check. X to the 4 minus 3x squared plus 1. X, okay, yeah, we got it, Okay, sweet. So, yeah, so here I have the red line. If you look at the red line here, this is the linearization of the blue function at this purple dot. So I can move it around, and if I put the purple dot at 0, you can see that we have an approximator of our function, but it's extremely shitty. The only place it's good, and I'm going to zoom in a whole bunch so you can see this, if I zoom in a whole bunch to this purple dot, the linear approximator is actually pretty good, like right around here, from here to here. You see that? And if I keep zooming in, you'll notice that it's actually really, really fucking good, like right around that point. But if you zoom out and you wanted to use the red line to approximate the function value when x equals, like if we look over here, when x equals 4, the red line would have generated a height of 1, while the blue line would have generated a height of God knows what. It's way, way up there. Okay, so you can see that our linear approximator only really works well for points near our center point. That's what it means to center it there. I can center it somewhere else. I can center it there. And now the linear approximation only works well here for x values close to 0.5. Okay, I hope that makes sense. I hope that makes it clear. What do they want in this question? They want find the linearization L of x of the function thing at x equals 1. So we just put this thing at 1. 1. Boop, there we go. So really what they're asking for is find the equation of this line. That's what L of x is. That means the equation of that line. So, you can do that whatever way you want. You're probably going to have to take the derivative. What did I even write here? Yeah, you need two things. Which two things? You need what for a line? You need a slope and you need a point or a y-intercept or whatever. From our function here, we can take the derivative, and that's going to give us our slope, easy peasy. And we can find our other point of the line by just plugging in x equals 1 into this function. It's going to generate your point. So that's really all they're asking for. And then for this, you input that function, whatever the function is. In other words, the equation of that line, that's what they're asking for. That's the answer in this case. So I hope that helps. That's problem 1 of Math 104, Weber 10. And as always, if you want me to personally help you pass your course, click in the description and you can sign up and I will help you. So thanks for watching, guys, and fucking rock on.